All right, everyone, get ready for another deep dive. Today, we're going to be taking a closer look at a brand new algorithm
Mhm.
that's trying to shake up the world of large language models, or LLMs, as you might have seen them called online. We're talking Reinforce plus plus,
That's the one.
and it's all about getting these LLMs to, well, behave a little better, making
Yeah.
sure they're actually aligned with what we humans want them to do.
Yeah, alignment's the big thing everyone's talking about these days, right? And this paper we're looking at today, it's pretty fascinating stuff, actually. The researchers kind of took a step back and looked at all the ways we're already using RLHF, reinforcement learning from human feedback, to try and make LLMs better.
Right.
And they thought, hey, what if we try something a little different? Streamline the whole process, maybe even get better results while we're at it.
So like decluttering the algorithm to make it work more efficiently?
Exactly. You see, the methods we're using now, like PPO, they can be really effective, but they're also computationally expensive. They need these complex critic networks to work, and that takes a lot of.
All right, everyone, get ready for another deep dive. Today, we're going to be taking a closer look at a brand new algorithm
Hmm.
that's trying to shake up the world of large language models, or LLMs, as you might have seen them called online. We're talking Reinforce plus
That's
plus,
the one.
and it's all about getting these LLMs to, well, behave a little better, making sure they're actually aligned with what we humans want them to do.
Yeah, alignment's the big thing everyone's talking about these days, right? And this paper we're looking at today is pretty fascinating stuff, actually. The researchers kind of took a step back and looked at all the ways we're already using RLHF, reinforcement learning from human feedback to try and make LLMs better.
Right.
And they thought, hey, what if we try something a little different? Streamline the whole. Oh, hey, our listener wants to join in. What's up?
Hey there, thanks for having me. Can we just go through the key points of this study?
Okay, I hear you. You want to get right to the key points, right?
Yeah, that's totally understandable. Let's make sure we get to the core of what makes Reinforce plus plus so interesting.
And we will. So we'll focus on what the algorithm does and how it improves on existing methods and what the big deal is.
Right, we'll make it snappy and focused, but we'll still hit all the key details from the study that we were planning on covering.
Sounds good. Let's do it. So reinforce plus plus A, it's all about finding a balance.
Yeah, making things efficient, but also stable. That's the idea.
Okay, so how does reinforce plus plus actually work? Walk us through the basics.
Well, think of it like training a dog. You give it a treat when it does well.
Okay, so rewards, got it.
But we're dealing with a massive language model here, not a dog. And instead of treats, we have feedback.
Right, it's trying to figure out how to get as many of those rewards as possible, and that means learning to do what we want, right?
Exactly. And Reinforce Plus Plus has a few clever techniques to make that happen. A big one is the token level KL penalty.
Okay, that sounds technical.
It's like a leash, keeping the model from straying too far from its initial training as it learns new things.
So it's a safety net, making sure the model doesn't suddenly go off the rails.
Exactly. It's a balance. It learns, but it doesn't go completely wild.
That makes sense. So it's like a gentle nudge in the right direction.
Yep. Another enhancement is the PPO clip integration. Remember PPO, that powerful but computationally expensive method?
Yeah, the one you mentioned earlier.
Reinforce plus plus borrows something from it called clipping, but it doesn't need the critic network like PPO does.
So it's like getting the benefits without all the cost.
Exactly. It limits how much the model can change during training.
So it's more controlled, less likely to suddenly veer off course.
Precisely, like setting guardrails for learning.
These enhancements sound great, but how does it actually do? Did they test it?
They did. They compared it to PPO and GRPO on both general and math datasets.
So they really tested different challenges.
And it did great. It was way more stable than GRPO, especially with preventing reward and length hacking.
Reward hacking, what's that?
It's when the LLM finds a shortcut to max out rewards without actually learning what we want.
So it's like figuring out the test without knowing the material.
Yes. Reinforce plus plus is designed to make those shortcuts harder to pull off.
Got it. So it's more stable than GPO, but how does it compare to PPO?
This is where things get really exciting. It got the same level of performance as PPO, but it was much faster and used less memory.
So same great results, but at a fraction of the cost.
Yeah. For instance, they trained LMA3 8B in just 42 hours, while PPO took 60 hours on the same hardware.
That's a huge time difference.
It is, so it's faster and cheaper and just as effective as PPO.
Okay, so is reinforced plus a big deal?
It definitely could be. It's a more efficient way to get the most out of these models.
Right. So what does all of this mean for people who use LLMs every day?
Think of all the times your autocorrect messes up what you're trying to say, or when a spam filter grabs an important email.
Okay, yeah.
Those are times when AI tries to do what we want, align with our preferences, but sometimes just misses the mark.
And as these models get more powerful, the stakes get even higher.
Exactly. Imagine